what do you see, Life of Pi Marshmallow? What do you see when you look into the ocean here? Me, I catching the hourglass or the snowflake right there at that point in time. Just one wild particle out here in the outer space, or the stone mill is like, was that one? I don't know. I've seen him do it a million times, but he did it a million times differently, right? You know, in the hourglass of putting one to the next one in the qubits here. What is a hyperbola? What is the hyperbola? Deriving the equation of hyperbola.
Hello.
Sounds like some Greek mythology bullshit about taking on a 7-headed
hyperbola. This is one of the conic sections. Today we're going to derive the general equation for a hyperbola, but we're going to do it in a way which is a little bit easier than doing it in general. We're going to do it with a particular example with particular numbers, and the algebra is difficult, but maybe a little bit easier than doing it in general. And then I'll say something in the end about doing it in general. Okay, so here is a hyperbola. What is a hyperbola? Well, there are many equivalent definitions of hyperbola, but the one that we're going to base this derivation on is the one which is the set of all points such that the differences in the distances to the foci is a constant.
If I was good and I knew I was good, I don't really need challenge time.
I'm pretty
good about my math. The one snowflake passing through here is going to be like, in the area for this guy, you're going to know what
F2, and these foci are located at -5, 0, and 5, 0.
Do.
Really, what I did is to establish a coordinate system in such a way that these 2 points have those coordinates. And A and B are the vertices of my hyperbola. They're the places where the hyperbola intersect.
Now that we got that shit out of the way, now let's take it to a version of calc where I need that in the stone mill, and that brings us right back to the water cooler in class at this chalkboard, partner. It expresses some of this neat little stuff that'll come up as an example of what is on the board today.
What's true is, if I take any point
is it that one?
I knew it. On the hyperbola,
there it is. Gravity, time, well, and
I will call it x. And
Teddy right there sitting on whatever it is.
From x to one of the foci.
So why there? Well, there's actually a spectrum of it. There is just one of the spectrums. Let's call that radio, microwave,
the other focus F2,
the indivisible light, because I can do what I want with that. And then gamma. But I can put gamma inside here and call that between the operation visible light, X and Y, pretty much squared away. And the triangulation gives me 2 points, IH. Length, shortest distance, 200 mile an hour, 2x4, pass through the pipe stay. It's hurricane outside, rain shadow problem. Not along you mentioned, it's probably a bad day for a lot of other things too. Like normally fish would be fine, hurricanes, they don't like that. Nothing likes it really. King George, the Constitution. Washington.
Maybe I'll call this Y.
King George Washington.
And if I go from Y to the near focus, and from Y to the far focus,
you get a square at an angle.
This segment,
here's the center mass of what that is. Now I have to shift this X and Y to give me a plane. And that plane is something square that I know how to write on
F1x, that
A1 Fx is to do the saw. You're going to be up here with the wrench in this angle right here, and I have to figure out how to draw the picture doing it. That's a hyperbola. It may not feel like a hyperbola at first, but about 15 minutes into that, after this conversation, the skid steer safety 300 IQ thing, you're like, damn, it is a hyperbola. Look at this thing coming at me mind-wise. Somebody feeding it after midnight and getting away.
You get a kind of a circle.
And all of a sudden, here on Entropy of the Chalkboard, zombies start coming up out of the grave.
This out is this red line here. And if I were to perform the same move by sort of putting my compass on X and rotating this F2
So learning curve is pretty cool. We could slide that in here for the...
Could be better. Not using an actual compass.
The heads and shoulders on this economics here.
Then I get this.
And that's what it'll really do. The operator was supposed to change from hydrogen to oxygen, neutron star, did some fancy stuff after, or something come in here and it ate it. Didn't agree with it, or did agree with it, and did exactly what physics was supposed to do. But in that way,
these vertices A and B are
feeds and speeds from Hoover Dam today, direct feed, like old school Snap-on tools. They're all mechanical. They don't have any circuitry or Milwaukee AVE learning curve. You can learn most of the stone mill in one day. I did that one day. You want me to do at least that again?
Then I kind
That's
of
a
get
hyperbola.
a sort of thing that looks
It's also a Fibonacci
like
sequence.
this, and I have this sort of
And I believe your Fibonacci sequence would diverge right there for a lot of reasons, but let me get you back here on the farm for a minute. Do your duty. You're going to want to make a list of things that you want to do. Okay. Okay, you believe that that's what that's worth inside here, and it's just going to keep piling up. And at some point in time, I'll be like, I'm just going to ask you to do stuff. You don't clean up that pile of wood. I mean, why would I keep you around here if it's my duty to do that? And change these numbers and put another triangulation inside here. About who's got more grains of sand on this semicircle here?
The other
Why they
important
come to
thing
me
is
first?
to well, maybe we just start. Okay, so
And that's the twister on that. So it's
Give me a
it's
second
a
while
tornado
I
coming
erase
at me. I'm on the highway driving on this road here, and I have to figure out the spin hyperbola. Yeah, there you go.
Okay. So
And then you're
good.
inside the pipes for
And
twister theory, right? Because this thing is that little drawing in twister
that's the
theory with
picture
the
of it
center
there,
core on
but
X and
I
Y, and
can-
it's an electron shooting this way or this way on a Feynman diagram. If I put the momentum clink,
all right.
clink, and the NP orders
That
clink,
is
clink,
F1.
and this thing shoots off in this
B,
direction.
and
And maybe there's a mirror force on that.
Alright, what I would
Well,
like to
Larry can do this,
now
but this asshole's
is
been scoring
to,
down here past -0.
come up
I
with
need to
the
know why. I
general
mean, this is
equation
normal operating
for this
procedure, a
particular
human being, and I
hyperbola.
can make money off of
And
this.
in
It
order
just
to
takes
do
a
that,
hell of
I
a
need
lot
to pick
longer.
an
And usually
arbitrary,
between the operator and what I
point
need
on
him
this
to be, I need
hyperbola.
him to
So
be between
I'll do
0
that,
and 1 here on the first day. Give me the area
I
of
can put a
hyperbola.
point over here on this right branch.